I'm going to talk today about digital microscopes and how they're beginning to overtake optical microscopes on the production floor, and give you an idea of the reasoning and some of the benefits of a digital microscope. Here is a typical digital microscope, obviously a stand, a boom, and the camera out here on the end. So they're very simple to use. You place the board underneath and the image appears on a standard monitor. Of course, you see no eyepieces, so this is a completely digital system. The main reason why these digital systems have become popular is with the recent availability of a reasonably priced video camera that's high def and has a high enough frame rate such that a user will not notice any lag when watching the video and moving their board underneath the camera. So now, basically 1080p and a 60 hertz frame rate are fairly standard in a mid-priced microscope such as the ones we're talking about here today. Now the other thing is, when you have something digital, obviously it opens up an environment for adding a built-in computer and with a computer, of course, software applications. So obviously on an optical microscope, there's no capability of running software on it because it's a purely analog device. So with these items in mind, and a couple of others which we'll talk about as well, the cost-performance trade-off is sort of tipping towards the digital systems now. On the people side, there are some ergonomic and health benefits that probably no one's really thought about too much. I'll discuss those in a future slide. The other issue here is that, again, as I mentioned, these are very simple devices to use. They're autofocus. Basically, all you do is you have a zoom in and out and maybe a capture button to capture an image. So again, very easy to use, minimal training for new operators. And the other thing is, without an eyepiece, everyone is looking at the same thing at the same time. So we have a screen. If we're doing collaborative work, we're both looking at the screen. We're not going back and forth to an eyepiece. I'm sure we've all been there before where someone sets something up in the microscope and then you look in and you can't see what they're talking about, and then they look in and they try and position a pencil or something like that to point to what they want, and then you look in and and so on. It goes back and forth and back and forth. Here, of course, we're both looking at the same image at the same time. So it makes collaborative teamwork really easy to perform. I talked about the software. We have a lot of different software applications for a lot of different fields. Some of them are related to the agriculture industry, looking at seeds, others in the food industry. But we have a handful of here that are nicely designed and usable in the electronics industry. Some of them are fairly usable across all industries, but two of them have been designed specifically for electronics, and that is the DX overlay application that we have, and also an image comparison application. And I'm going to demonstrate both of those applications for you in a few moments. We also have a ruler, which is similar to a graticule on screen, so you can make measurements right on screen. We also have another app where you can make substantially more accurate measurements, create annotations, and save these images for documentation purposes. We also have an application called focus stacking, and what that does is it takes an image. If you have an image where you have items on there of various heights, and due to the depth of field of the system, you may have some of the items in focus and some out of focus. So with focus stacking, what we can do is take a stack of separate images at different focal points and then create one perfectly in focus image. For documentation purposes, we can add watermarks to our images. And we have another app that is sometimes kind of interesting, where we can draw some verification lines, have them on the screen superimposed over the live image. And this quickly allows operators to check the dimensional properties of their product. Now, we talked about the ergo health benefits, and what we found through various studies is that when an operator is hunched over an optical microscope for an entire shift, they oftentimes get a lot of neck and shoulder pain and eye strain, obviously, particularly, most likely if they wear glasses in the first place. So, of course, we have no eyepieces here, so we're just looking at a computer screen. So the person can be positioned in an ergonomic position and eliminate those strains. The other item that's come to light most recently with COVID is that eyepieces are actually quite unhygienic. So if you have a bunch of people all putting their eyes on an eyepiece, it's not an ideal situation in this COVID era. Obviously, we have some benefits related to these things, and it just all adds up in making the digital decision a lot easier. We saw a picture of this particular microscope on the first screen. With its adjustable height stand, it really allows us to make use of a variety of different lens and lighting options here. So it allows us to go everything from a macro lens up to in the range of 500 or 600x on magnification. So this system is mostly used in the lab or for quality investigations. We have another microscope here. There's the camera, and this is on an adjustable arm. You can mount it on a bench and use it that way, but oftentimes we see this on the production floor, mounted over the top of a conveyor. So the operator can stop the board right on the SMT line, use the microscope, move it around, look at various different sections, and then either pass or fail as you go. Then this system here, you see this is on a fixed height stand, and there's the camera out here on the end. So this system is designed for general inspection, where basically you can just walk up, put the board down here, and do your inspection. It's a very, very simple, very easy to use system. Now I'm going to switch over and do a demo. So we'll switch my video. And there, now we have the microscope. We have a live image. I know we talked about zero lag. It's certainly zero lag here. I don't know how it's turning out at the end of the internet on your desk there. But so here we have a board, and we can adjust it here, obviously manually. Here's the zoom. I can zoom in with this lens. I can zoom into about 40x. And we can move around. And one thing I'm fascinated to see on this board are these three inductors here. You can see one with 2 turns, one with 3 turns, and one with 4 turns. So kind of an interesting part. Anyways, what I'm going to show you on this section of circuitry here is the image compare application. So let me get that rolling. I'll run that app, and you see a little screen opens up at the top. So what we'll do here is we have templates that we can load. So if you're doing this in production environment, what you would do is you would save your golden board as a template, and then you just recall the template and then put your sample board under and perform the the comparison. But for today, I'm going to actually create a template, and I'll show you how that's done. So we basically work our way across here. So we capture our reference image, and when we put our sample board in, it's going to auto-align them, so we need to enter some fiducial points here. So I'll just pick a couple of points. You just drag these guys over, somewhere around opposite corners. I'm not going to be too accurate here, but will be, not too bad. Okay, and then what it will do is it will create the template, and now it'll create a live view with my template in the background. So I'm going to remove the board, and now we're seeing the pad that I have underneath superimposed under the board. So here's my my sample board. So you can get it fairly close. You can spend a lot of time and line it up, but since the tool is going to do that for you, you don't have to worry too much because it has the fiducials. So now I can capture the sample. You saw how it automatically lined them up. And then I can come across here and I can toggle these two images. So that's a toggle between my golden board and now my sample board. So the nice thing about the toggle is that the eye is very quickly drawn to any changes. So here you can see that there are very few changes. Perhaps one noticeable exception. You may have noticed there's a missing component at the top, and some others are just some parts shifted around and looks like a change in a date code on that max part there. So that gives you an idea of how this product works. We also have a split screen where we can show both at the same time or slide one back across the other as well. So I'm going to close that off. Now, of course, we're back to a live image. So I'm going to put another board on here. And this particular board I have DXF overlay for. So we'll be using that to show you how the DFX overlay tool works. So back to my menu, DXF overlay. Now I have a variety of overlays saved. Basically, they're loaded on the microscope. And this is the one for this particular board. So that brings it in. I can move this out of the way. You can see the overlay there. We have a little option here to enhance the contrast on the overlay. And then we have an option to center the search result. So I'll turn that on as well. So now what I do is I put my board on there and I just manually line them up. It's basically as simple as that. So that's it, they're lined up. Now this scales with the zoom, so if I zoom in or out, the overlay scales with it. And now over here I can enter in what I'm looking for. So let's say we want to find C116. And I'll say find. Now, since I've clicked on center the search, you'll see what it's done. It's highlighted C116. It's moved it to the center of the screen. And now what I'm to do is move my board with it. And then I can find it on the board. Now if I need to examine that part, I can zoom in. And you can turn off the overlay. You can see there's a hide overlay option, or you can simply move it to the side, examine your part. I don't know what you have to examine for, but in this case it's there. It looks like it's well soldered. So I'm basically done. Now let's say we want to go and find Q1. Again, obviously the board has moved, and we go and line it up, and that finds us Q1. So what I'll do there again is move it to the side, and I can do my inspection. You can see it's present, and it looks like it's well soldered. So I've inspected my two components. Now what you can do here is you can enter a list of components that maybe you need to inspect on a board, or you can use a barcode to enter from a list of components and go through a predetermined list. So it's a very handy system in that way. And this application was actually asked for by one of our customers. So we developed it basically to their spec. And they've obviously been very happy with it. And that's something that TAGARNO is actually very good about. They work closely with their customers, and if you need an app to do something specific on a microscope, or if you need maybe a change to an app, then obviously we can run it by the R&D staff there and see what can be done. So that's my presentation for today. I hope that has given you a good idea of some of the capabilities of the new digital microscopes with all this power built in now, and I'm sure that over time it's just going to get better and better. So we'll see fewer and fewer old analog microscopes. So we'll break for now and see if we have any questions available. Thank you.